We want to find the coordinates and types of turning point on the curve y is x cubed minus 3x. The first thing to do is differentiate. dy dx is 3x squared minus 3. Turning points occur when dy dx is equal to 0. So we need to set 3x squared minus 3 equal to 0. We get 3x squared is equal to 3, and dividing by 3 gives x squared is equal to 1. So x is equal to plus or minus 1. We need the y-coordinates corresponding to these points. If x is equal to 1, y would be 1 cubed minus 3 times 1, substituting back into the original y equation. And this is 1 take away 3, which is minus 2. So the coordinates of this turning point are 1, minus 2. When x is equal to minus 1, substituting into the original y equation gives minus 1 cubed, take away 3 times minus 1. This is minus 1 add 3, which is 2. So the coordinates of this turning point are minus 1, 2. We can investigate the nature of these turning points using the second derivative, d2y dx squared. We differentiate dy dx again, and we get 6x. When x is equal to 1, d2y dx squared is equal to 6 times 1, which is 6, and this is positive, telling us that we have a minimum. So we have a minimum at 1 minus 2. When x is equal to minus 1, d2y dx squared will be equal to 6 times minus 1, which is minus 6. And this is negative, which tells us that we have a maximum point. So we have a maximum at minus 1, 2. We could also have investigated these turning points using the sine table. X and dy dx. If we start by looking at the turning point when x is minus 1, a point to the left is minus 2, and a point to the right is 0. And we know that the other turning point is at 1, so there are no other turning points between minus 2 and 0 other than the one at minus 1. We know the turning point is at minus 1, so the gradient is 0. We need to look at minus 2, evaluate dy dx with x equal to minus 2, and we get 12 take away 3, which is 9. The important thing is that this is positive. When x equals 0, dy dx is 3 times 0 squared, take away 3, which is minus 3. And so we have a negative. Positive across negative means we've got a maximum. So we have a maximum at minus 1, 2. Finally, looking at the other turning point, So we draw our sine table. The turning point is at 1. A point to the left is 0 and to the right is 2. And since we know the other turning point is at -1, the only turning point we have in the range 0 to 2 is the one at 1. The turning point is at 1, so the gradient here is 0. We've already done the 0, and we need to evaluate dy dx for x equals 2. So we get 12 take away 3, which is 9, and this is positive. So we have negative across positive, and this is a minimum shape, so we have a minimum at 1 minus 2.